Alright, I'm going to bring you through an example of what I'm doing to test the drop zone trampoline tester. A trampoline frame we put in here with fabric over it, rubber bands, whatever. And essentially, the visitor would come and press this button, golf ball will drop in between these sensors. And we have two planes of emitters and detectors. This plane has the detectors on this side with the emitters on this side, and the bottom plane is the opposite. I have an oscilloscope which is measuring directly the output from those sensors, and we'll find the time between when the golf ball breaks the first plane on the way up and then breaks the second plane on the way down. The first plane is in yellow, the second plane is in blue. And then over here we have the serial monitor readout from the Arduino, and we'll be able to compare with the Arduino what these sensor boards have come up with for a time. Okay, so let's give it a whirl. Ready to go. About 21 centimeters. And let's find the delta T of that. So we have our first plane here. This is when it broke it on the way down. This is the second plane on the way down. Second plane on the way back up. First plane on the way back up. Let's move the cursor a little bit just so you can see where it is. Okay, so that's our first one. And then it's breaking the plane, first plane on the way down, and then the second plane on the way down. So let's move that cursor too. Okay, going over there. Looks like we have a delta T of about 392 milliseconds. And okay, so that's what the oscilloscope is reading with its own clock cycle, which is at 50 megahertz, 2 channels. And let's go to what we have from the Arduino. Looks like our delta T here is about 392.24 milliseconds. So 392.24. Wow, that lines up pretty well. Damn, that's pretty accurate. So that's an example of one sort of test that we do over and over again for some of the balls that bounce really high, some of the balls that bounce really low, ones that move horizontally a lot that could potentially trigger the interrupt on the Arduino multiple times. And so yeah, we have a good filtering process, but at this point I believe it to be more of a software problem than a hardware or electronics problem. So it's looking pretty good.